This is the Honors Math 2 Unit 1 review. Should look like this. Let's get started working our way through. So we start with number 1, which is 5a to the 4th minus 2a to the 3rd plus 4a squared plus 5a. Adding to that, 5a cubed minus 5a squared plus 2. So this is going to be a combining like terms. I have 1a to the 4th. So that one's taken care of. I have a negative 2a to the 3rd and a 5a to the 3rd. So that will be plus 3a to the 3rd. I have a 4 minus a 5 for the a squared. That's negative a squared. 1 5a. Takes care of those. And then plus 2. For number 2, we're now looking at 4m to the 4th minus 3m to the 3rd plus 6m squared plus 5m minus 4. All of that is subtracted from, and subtracting that, 6m third is 8m squared minus 3m plus 1. Now I'm going to distribute out the negatives, so I'm going to make that positive. We go negative, positive, positive, negative. So now it's 4m squared by itself, or 4m to the 4th by itself. I have a negative 3 and a negative 6, so that's negative 9m to the 3rd. I have a 6 and an 8, so that's 14m squared. I have a 5m and a 3m, that's 8m. And then a negative 4, negative 1 is negative 5. For number 3, there is no number 3. Fantastic. Number 4, we're going to go 2x plus 1, x plus 4. So I'm going to do the multiplying by the box method that I used in class. So we're going to go 2x plus 1, x plus 4. X and 2x is 2x squared. X and 1 is x. We then have 8x here and a 4. This I get me 2x squared. This is x, and 8x is 9x, and then plus 4. For number 5, we go 2x squared minus 3 and x minus 2. I'm going to do the same thing. So we have 2x squared minus 3, x minus 2. So we go 2x to the 3rd minus 3x. That's negative 4x squared and positive 6. These are not like terms, and that's fine. I'm just going to write in descending order. 2x to the 3rd minus 4x squared minus 3x plus 6. Now we're looking at number 6. So for this one, we have 6x squared plus 5, 2x to the 3rd plus 1. So with our box, we now have 6x squared and 2x to the 3rd gives me 12x to the 5th. We go 10x to the 3rd here, 6x squared and 5. Descending order, I get 12x to the 5th plus 10x to the 3rd plus 6x squared plus 5. Number 7, 1 minus 2x, 1 plus 2x. I'm going to multiply by a box here. So we have 1, negative 2x, positive 2x, and negative 4x squared. I notice my like terms become 0. So that's 1 minus 4x squared is my solution. But what you also may notice is this was a difference of 2 squares, and we could have used that idea to help us get to the solution faster. In either case, we get that. For number 8, we have 2x plus 5y, and that is squared. It is not 2x squared, 5y squared, and just distribute it in. We're going to do the box still. We got 4x squared, 10xy, 10xy, and 25y squared. So this becomes 4x squared 10 and 10 is 20 xy, and 25y squared. Let's go to number 9. So this one is another difference of two squares. So instead of using the box, I'm going to kind of predict what's going to happen. Now, difference of two squares, if it's a squared minus b squared, is a plus b, a minus b. So here, I'm going to put this together. It looks like it's going to be 2x squared squared minus 3 squared. So that comes out to be 4x to the 4th minus 9. Would have been the same thing as if we used box, but it's a good pattern if we do see that. So now for 10, I have x minus 2 to the 3rd. So this is like saying x minus 2 times x minus 2 times x minus 2. I'm going to go 2 at a time. So multiply the first 2 together. I get x squared minus 2x minus 2x and plus 4. So x squared minus 4x plus 4. Bring down the x minus 2 I have left over, and now multiply this trinomial by this binomial. So now we got x to the 3rd minus 4x squared and 4x, then a negative 2x squared, 8x, and negative 8. So I have x to the 3rd for sure. Negative 4x squared and negative 2x squared is negative 6x squared. 4x and 8x is 12x, and then the negative 8 at the end. So x minus 2 to the 3rd ended up here. Let's now go to number 11. So we got x plus 7, x plus 4, and x minus 7. Now, I can multiply in any order because of the commutative property. I'm going to look at these two first, which is a prime example of the difference of two squares. So this is actually going to be x squared minus 49. Then I'm going to multiply that by x plus 4. By seeing that, it saves me a little bit of time. So now I'm going to go x squared minus 49. X plus 4. We got x to the 3rd minus 49x, 4x squared, and that looks like negative 196. So it comes out to be x to the 3rd plus 4x squared minus 49x minus 196. Now for number 12, we have 4x squared minus 2x minus 1 times 3x minus 1. Now, even though this is a trinomial times a binomial, just treat it the same way. Use the box. You just change the number of rows or columns that you have. It still works. I'm going to go 3 by 1 here. So we got 12x to the 3rd minus 6x squared minus 3x minus 4x squared, 2x, and 1. So 12x to the 3rd is good. Negative 6, negative 4 gives me negative 10x squared. Negative 3 and 2 gives me negative x, and then a plus 1 at the end. Now for 13, we have a box here, and we got to figure out the area of the shaded region. So I'm going to figure out the area of the whole box first. And so that's going to be 21x plus 8 times 4x. And then I'm going to subtract from that the area of the whole. Because it's saying the area of the whole thing minus the whole, that's going to give me the area of the shaded part. So the area of the whole is going to be 2x times 3x minus 4. So here it's really just going to be a distributive property. That's going to be 84x squared minus or plus 32x. And then over here I have distributive property again, 6x squared minus 8x. Now we have to be careful that this is subtraction, so I'm going to distribute out the negative. And so now it's saying 84x squared minus 6x squared is 78x squared. And then 32x plus 8x is 40x. So the area of the shaded region is 78x squared plus 40x units squared. All right, so now we go on to factor. So let's change the colors. So 14, we have y squared plus 8y. To factor this one, I'm going to look for common factors first. I can take a y out of both terms, and you get y times y plus 8. 15, I have 5m to the 5th, n plus 10m to the 3rd. I'm going to take out my common factors. I have 5 in both of them. If I look at m to the 5th and m to the 3rd, I have at least an m to the 3rd in each term, and I don't have an n in both, so I'm not going to have that. So 5m to the 3rd takes out of this and leaves 2 m's and an n. From 10m to the 3rd, it takes out a 5 and an m to the 3rd, leaves us with just a 2. So 5m to the 3rd, m squared n plus 2 are my two factors. For 16, we have 4a to the 4th, b to the 4th, minus 2a to the 3rd, b squared, plus 6a squared. I could take out a 2 from everything. If I have a to the 4th cubed and squared, I can take out 2. And not all the terms have a b, so I will not take that out. I'm left with 2, and that's an a squared b to the 4th. Middle term, I'm left with negative 1. I'm not going to write the 1 though. An a and b squared. And then the last term, I'm left with a 3. So now it's 2a squared times 2a squared b to the 4th minus ab squared plus 3. Can't factor that down anymore, and I'm done. 17, we have 9a squared minus 16. This, we recognize 9 and 16 as squares, so this is going to be a difference of 2 squares. So it looks like we're going to go 3a and 4 are the 2 squares, and then our rule tells us we make one positive, one negative. So 3a plus 4, 3a minus 4. 18, we have 100 y to the 6th minus 49 y to the 4th. Also a difference of 2 squares problem, but we could also maybe factor out a common factor. Let's take out the y to the 4th. That might clean things up. So now I have 100 y squared minus 49. So this, with the y's out, it cleans it up a little bit. So I could make this into 10y minus 7, 10y plus 7. So my factors are y to the 4th, 10y minus 7, 10y plus 7. For 19, we go 27x squared minus 48y squared. Looks like I can factor a 3 out of each of these. So I'm going to take a 3 out, and I got 9x squared minus 16y squared, which actually shows this is a nice difference of 2 squares. So that's 3 times 3x minus 4y, 3x plus 4y. For 20, oh, my numbering's off there. This is the first number 20. It should be x squared minus 16x plus 64. I'm looking for a way to multiply to 64. That adds to negative 16. If we multiply negative 8 and negative 8, we get x minus 8 as my factors. We could also write that as x minus 8 squared. Now for 21, we got 4x squared plus 40x plus 100. I have common factors here. It's going to make it easier if I factor out a 4. So I have x squared plus 10x plus 25. Now I'm looking to multiply to 25 adds to 10. I can do 5 and 5. So we could do 4 times x plus 5 times x plus 5, or just 4 times x plus 5 quantity squared. 22, which actually says 20, is x squared plus 6xy minus 72y squared. Now I'm going to treat these x's and y's. I got x, y, x, y. So that's how the form is going to be, what gets me the x squared and the y squared. I just need to fill in the numbers. So don't get lost in having all those variables. I'm still thinking, how can I multiply to 72 that adds to 6? 72 is 7, not 7, 8 and 9, which doesn't help me, but it's also 12 and 6. Now, I want a negative product, positive sum, so I'm going to make the 12 positive, 6 negative, gives me negative 72, but still adds to positive 6. So we're going to go x plus 12y, x minus 6y. Now for 23, we have 12x squared plus 31x plus 20. I'm looking at multiplying to 240 that adds to 31. So if we start writing out our factors of 240, I have 1 and 240, 2 and 120, 3 and 80. We could do 4 and 60, 5 and 48, 6 and 40, 7, nope, 8 and 30. We could do 9, oh, not divisible by 9. How about 10? 10 and 24. How about 12 and 20? We can check if we have a sum here, any of them adding up to 31. What if we went now 15 and 16? Now that one actually looks good. So I'm going to take 15 and 16, and now we're going to go 12x squared, break 31x into two terms, 15x and 16x, to give me 4 terms. Now I'm going to use factor by grouping. From the first two I can take out, it looks like a 3x, and it leaves me with 4x plus 5. The second terms I can factor out of 4, leaves me with 4x plus 5. I take the 4x plus 5 out of both terms, leaves me with 3x plus 4, and there is my factored result. Now let's go to 24. For 24, we have 6x squared plus 13xy plus 6y squared. So I'm multiplying to 36. That adds to 13. So for 36, we have, of course, 6 and 6 is our common one. 12 and 3. We could do 9 and 4, which looks good, adds to 12. So 13. So I'm going to go 6x squared plus 9xy plus 4xy plus 6y squared. Factor out a 3x from the first two terms. It leaves me with 2x plus 3y. Last two terms, I'm going to factor out a 2y. Leaves me with 2x plus 3y. Now I take the 2x plus 3y out of each, and I'm left with 3x plus 2y, and there is my factored result. For 25, we have 12x to the 4th plus 28 x squared y squared minus 24 y squared. We got a lot of terms here. Let's simplify what we can. Let's factor out a 4. That leaves me with 3x to the fourth plus 7x squared y squared minus 6y squared. Now, I'm going to take these, let's square bracket them. I'm going to factor this result. So, multiplies to looks like negative 18, adds to 7. I'm thinking 9 and negative 2. So I'm just going to leave that 4 kind of here. I'll bring it back later. But I'm going to go 3x to the fourth plus 9x squared y squared minus 2x squared y squared minus 6y squared. Factor from the first two. 3x squared comes out. X squared remains. Looks like 3y squared remains. From the next term, the factor of the negative 2y squared, I have left an x squared plus 3. We're off here. We actually need to fix a typo. This, let's just make this y. Leave that as y squared, otherwise we're going to have an issue. All right, so now we're left with plus 3 there. These should still be y's. All right, so let's take back. This was y squared. I factored here, broke it apart to 9x squared y, negative 2x squared y. This is still negative 6y squared. From this, I factored out a 3x, got x squared plus 3y. This I factored out a negative 2y, leaves me with x squared plus 3y. So they match. So bring down the 4, then x squared plus 3y, and 3x squared minus 2y is my result. Now 26 is actually the same as 23. That is an error we also have on here, so treat those as the same. You don't need to do 26, see 23. Let's go to 27. I got 14x squared plus 35x plus 14. I'm going to factor out a 7, and I got 7x, actually that's 2x squared plus 5x plus 2. I'm looking to multiply to 4, add to 5, so I'm thinking 4 and 1. So 2x squared plus 4x plus x plus 2. Take out a 2x. Take out a 1. So this becomes x plus 2, 2x plus 1, bringing down the original 7 for our factored result. For 28, we have 3x squared minus 4x plus 1. I'm going to factor out, or I'm going to look at multiplying to 3 that adds to negative 4. So negative 3, negative 1 would be a good solution. So we're going to 3x squared minus 3x minus x plus 1. I can factor out a 3x, and I have x minus 1. I can factor out a negative 1, and I have x minus 1. So my factors are 3x minus 1 and x minus 1. Next, for 29, we have x cubed plus 3x squared plus 2x plus 6. This is going to be a factor by grouping. I'm going to take out x squared. I'm left with x plus 3. I'm going to take out a 2. I'm left with x plus 3. So I get x plus 3, and then the remaining x squared plus 2. Number 30, we have 8a to the third minus 12a squared plus 6a minus 9. We're going to factor out a 4a squared from the first two terms. That leaves us with 2a minus 3. Take out a 3, gives me a 2a minus 3. So 2a minus 3 was the common term. Left here is 4a squared plus 3 as my other factor. 2x squared minus 4x plus xz minus 2z. Treat it as still a factor by grouping. Take out a 2x, and I got x minus 2. I can take out a, looks like a z. I get x minus 2, so then I get x minus 2 and 2x plus z as my two factors. For 32, 4x to the 5th plus 6x to the 4th plus 6x to the 3rd plus 9x squared. I'm going to take out an x squared first. We got 4x to the 3rd plus 6x squared plus 6x plus 9. Now it's factored by grouping. Just leave the x squared on the outside. I'm going to take out a 2x squared from the first two. Leaves me with 2x plus 3. Take out a 3 from the next two. Leaves me with 2x plus 3. Now I take that x squared I had along. 2x plus 3 is one term. 2x squared plus 3 is the other. And I have my three factors. For 33, we need to factor y minus 6 squared plus x minus 1, y minus 6 without simplifying. So really it's saying they both have a y minus 6. I'm going to take that out of both terms. What I'm left with is this one had two of them, so it's got one left. And this one, when it's gone, all I'm left is this x minus 1, and that's really all we have to do. And for the simplifying, we don't need to multiply out. Leave it as that. Now 34, we're solving. I have 2x squared plus 6x equals 0. I'm going to factor out a 2x from the first two, or the two terms. I'm left with x plus 3 equals 0. By our zero product property, I'm going to set each factor equal to 0. So I have 2x equals 0, which gives me x equals 0. And x plus 3 equals 0. If I move the 3 over, I get x equals negative 3. So my two solutions are 0 and negative 3. In 35, I have 4x squared equals 25. If you ever have it where you have terms on either side of the parentheses, I'm going to move, or the equal sign, I'm going to move everything to the same side. And now, this is suddenly looks like a difference of two squares. So I'm going to factor this to be 2x minus 5, 2x plus 5 equals 0. I set both equal to 0. This first term, 2x minus 5, becomes 2x equals 5, and x equals 5 over 2. The second term becomes 2x equals negative 5, and x equals negative 5 over 2. So my two solutions are 5 over 2 and negative 5 over 2. For 36, we have 7x squared plus 15x plus 2 equals 0. Here I'm multiplying 14 to add to 15. I'm thinking 14 and 1 are what I want to use. So I'm going to factor that first. Let's factor out a 7x, and I get x plus 2. Factor out a 1, I get x plus 2. So now it's 7x plus 1, x plus 2 equals 0. Set both equal to 0. We get 7x equals negative 1, x equals negative 1/7, and then x equals negative 2. For 37, we got 20x to the 3rd minus 4x squared minus 72x equals 0. I'm going to factor out a common factor of 4x. Leaves me with 5x squared minus x minus 18. So now we're going to factor this trinomial. Looks like it's going to be a 5 and 18 is 90. Negative 90. That adds to negative 1. So I'm thinking negative 10 and positive 9. So let's go 5x squared minus 10x plus 9 minus 18. And we're just working within the trinomial right now. I'll bring back the 4x in a minute. So we take out a 5x, leaves us with x minus 2. We take out a 9. Oops, I forgot the x there. Leaves me with x minus 2. They match. That's good. So I have x minus 2 and 5x plus 9. Bring down the 4x. These are my factors. Now, I set each of these equal to 0. So I get x equals 0 from the 4x equals 0. X equals 2 from x minus 2 equals 0. And this one is 5x equals negative 9 and x equals negative 9 over 5. So my three solutions are there. Now we're going to factor some cubes. We'll start with 38. I have x cubed plus 125. We had the rule for this. We went over in section 6. This is like thinking of x to the third and 5 to the third. So when I factor it, it's going to become x plus 5, keeping the same sign. Then it's going to be x squared, one of each, and then the last one squared. We had same sign, opposite sign, always positive, and it's factored. 39. I'm going to go 216 x to the third minus y to the third. This term is like saying 6x to the third. So we'll go 6x minus y, keeping the same sign. Then we'll do the first term squared, 36x squared. One of each, 6xy, and then the last term squared, y squared. Same sign, opposite sign, always positive. For 40, we have 3x cubed plus 81. Now I'm going to factor out a common factor. Take that out. I get x cubed plus 27, which is going to factor a little nicer. So I go x plus 3, because 27 is 3 to the third. Then it's first term squared, both terms, last term squared, 3 squared. Same sign, opposite, always positive. So it's 3x plus 3 times x squared minus 3x plus 9. The last one of this set, let's see if I can fit it right here, is 41, which is x to the 6 plus 8. That's like we're saying x squared to the third and 2 to the third. So we're going to go first term, x squared and 2. Then I'm going to go this term squared, which is x to the fourth, one of each, 2x squared, and then the last term squared, 4. Now, same sign, plus, opposite, always positive. Now for 42, we have a rectangular prism has a volume of 6x to the third minus 28x squared minus 48x. We need three expressions that could represent the dimensions. All this means is factor. So I could factor out, it looks like a 2x from all of these. Leaves me with 3x squared minus 14x minus 24. And in doing that, now that's one factor, so I got 2x. I'm going to try to factor this one. So I have here negative 72 that adds to negative 14. Well, let's see. 72 is 18 times 4. So if I made 18 negative, 4 positive, that could work for me. So I got 3x squared minus 18x plus 4x minus 24. If I factor out a 3x, I get x minus 6. If I factor out a 4, I get x minus 6. So it looks like we get x minus 6, 3x plus 4. Bring down the 2x. Our possible dimensions are these three. 2x, x minus 6, and 3x plus 4. 43, we're going to do the same thing. We have x to the third plus 3x squared minus x minus 3. I'm going to do factor by grouping because I don't have a common factor. So let's take out an x squared. I'm left with x plus 3. Let's take out a negative 1, x plus 3. So this looks like x plus 3 and x squared minus 1, which actually looks like only two terms, but I got difference of two squares. So x squared minus 1 actually becomes x minus 1, x plus 1. Bring down the x plus 3. These are our three possible dimensions. Last, 44. We have same setup, 3x to the fourth plus 192x is our volume. We're given that the height is 3x, so we actually know we could factor that out. That gives me an x to the third plus, let's see what that reduces to. 64. So now that's the height. I need to find the possible lengths and widths of the solid, or the other two dimensions. So I'm just going to factor this, which we know is a sum of cubes, because this is x to the third and 4 to the third. So we're going to go 3x, we know that. Then it's going to be x plus 4, same sign. The x squared, one of each, 4 and x, and then the 4 squared, 16. Same, opposite, always positive. So our other two dimensions are x plus 4 and then x squared minus 4x plus 16.